Okay, so in addition to laws of exponents, because logarithms are just a different version of exponents, every property of exponents has a corresponding logarithmic property. So when we have the product rule, that is where we multiply with the same base, you add exponents. For logs, if you have two numbers multiplied together inside a logarithm, they can split into their own separate logarithms. So log base a of x times y equals log base a of x plus log base a of y. That only goes for multiplication inside of logarithms. You cannot split addition inside of logarithms. Similarly, the quotient rule, when you divide with the same base, you subtract exponents, becomes when you're dividing inside a logarithm, you can split them into two logarithms, but it will be subtraction between the two terms. Power rule for exponents is when you raise a power to a power, you multiply. For logarithms is if you have a number raised to a power inside of the logarithm, you can bring that power out in front and it's multiplied by the value of the logarithm without the exponent. And then lastly, the last two are the general rules. The zero power rule for exponents, anything to the zero power is 1. For logs, log base a of 1 is equal to 0. So any log base of 1 is 0. And lastly, anything to the first power is itself. For logarithms, if you have the log of a base of that same number inside the logarithm, it's always equal to 1. Now, generally, we can use usually the first three properties to either expand logarithms to where they all get their own, or condense them to where they're all inside one logarithm. So let's look at this first one. Log base 6 of 7 times 9. Multiplication can become addition, log base 6 of 7 plus log base 6 of 9. We can even go further than that. 9 is really 3 squared, so we can rewrite it as such. And when we have a number raised to a power, that power can come in front of the logarithm. So log base 6 of 7 plus 2 log base 6 of 3 is our expanded form of our logarithm. Let's try it again with number 2. Log base 9 of x squared over y to the 4th. So log base 9 of x squared minus the log base 9 of y to the 4th. Again, division becomes subtraction. It would be the same as if we moved it up to the numerator with a negative power. And we'll see why that would be the case when exponents can move out in front. Each of these has an exponent that moves to the front. So 2 log base 9 of x minus 4 log base 9 of y. Now, these can get relatively complicated overall. We'll do one on the next page. Log base b of the nth root of x cubed y to the 5th over z to the k. Okay, so one thing to note. This nth root is the same as raising everything to the 1 over n power. That gets distributed to everything on the inside, including the denominator. So log base b of x to the 3 over n, power to a power you multiply, y to the 5 over n, over z to the k over n. Now, anything multiplied in the numerator becomes an add when it gets separated. Anything divided by becomes subtract. So really we have log base b of x to the 3 over n plus log base b y to the 5 over n minus log base b of z to the k over n. Now for each of these, they have an exponent that comes out front, so 3 over n times the log base b of x plus 5 over n times the log base b of y minus k over n times the log base b of z. So these can get a little complicated. Sometimes expanding, what it helps us do is evaluate. This is usually more though for numbers, but occasionally with variables it does happen as well. Now, if we can expand, we can also contract to bring all of the logarithms into a single log using these same rules. We're just going backwards. So we'll do one of these. We'll do number 1. Log base 3 of x plus 2 plus log base 3 of x minus log base 3 of 2. So addition becomes multiplication inside the logarithm. X plus 2 times x. We can multiply those out. That's x squared plus 2x minus log base 3 of 2. Now subtraction becomes division, so this becomes log base 3, x squared plus 2x all over 2. So keep that in mind, it's just going backwards, but it's a similar process to before. Now when are these somewhat helpful? Particularly when we're evaluating logs without a calculator for numbers in particular. So the common log. The common log is the logarithm for our number system where the base is 10. Well, we tend to just think of this as log base 10. The truth is, the logarithm is also the logarithm with no base. So if you see a log without a base, it's a log base 10 problem. So this log of 10 to the third is really log base 10 of 10 to the third. I can bring the 3 out front, 3 times the log base 10 of 10. And what I know here is when the base matches the inside, this is 1, so this is 3 times 1, which is 3. Log of 0.0001 is really log base 10, 0.0001. You can look at this a few different ways. The number of zeros tells you how many powers. There are 4 digits after the decimal place. This is really 10 to the negative 4th power. Now we may see already that these are then going to cancel and my answer is going to be negative 4, or I can bring the negative 4 out front to see the same thing. But this thing is negative 4. Alternatively, if you know your decimal places, this is tenths, hundredths, thousandths, 10,000ths. You could have done log base 10 of 1 over 10,000 and taken that division and split it into subtraction and got the same answer. Now similarly, how our properties help, log of 5 plus log of 10 or log of 20. I actually don't know what log base 10 of 5 is because it's not 10 to a specific power. I also don't know what log base 10 of 20 is. However, I know addition between 2 logs with the same base can become multiplication on the inside. 5 times 20 is 100, so now this is log base 10 of 100. But 100 is 10 to the 2nd power, so this is 2. Now there'll be other examples on your homework. Log of 142. Your calculator has 2 different kinds of log buttons. It has log and it has what looks like an ln, which is the log of e, which we'll talk about in the next video. But you can use a calculator to find the ones that are even like this. So all you have to do is type log of whatever the number is, log of 142, and it gets an answer. This one happens to be 2.152. Just make sure you're rounding to whatever they tell you to round to. Log of 0.005832 is negative 2.234. And log of 2347 using a calculator is 3.371 rounded. That is all for this video.